In today's video, I want to show you how I solved problem number 3, auction, found here on the Solidity Challenges repo. So in order to get started, simply clone the repo and then open it up in your preferred editor. I'm over on the README for auction, and it gives a detailed description of the exploit, but the focus point is the last paragraph here. Your job is to create an attack contract that will disrupt the process and ensure the attacker has the highest bid. All right, so on auction.sol, they provide us with a contract, and we'll take a look at it from top to bottom. Starts with a fixed supply. So this will be what is going to be given to the highest bidder at the end of the auction. They have the winner address, end date, top bid, and owner. All makes sense. A mapping for the bids to addresses, and then your constructor, which will set all those state variables. Starts by setting the winner address as the deployer or the message.sender, with the top bid being 0. We then have 3 getters and 2 setters. So I'll skip over the getters, and we'll look at the winner withdraw, which is just 2 lines of code. The first one being a guard that ensures that the winner address is indeed message.sender. So you are the highest bidder when you call this method. And if you are, they will mint that fixed supply to you. Okay, so nothing jumps out here. And then we have make bid. So in order to actually become the highest bidder, we first have to make a bid. There's 2 guards I see. The first one where the current bidder is not message.sender. So if you're already the top bidder, you can't place a bid. If you are not, then it will take your value, and it has to just be greater than the value provided by the top bidder. Then it's going to make an external call where it's going to the previous bidder, I guess now, and pass his value back to him. So he's going to refund the previous highest bidder. After that's successful, it's going to go ahead and update the state with all the information of the new highest bidder. Okay, so first thing that jumps out is that they are updating state right here after they make an external call. And if you followed my other videos, particularly EtherStore, you'll realize that this is not the proper flow. This is leads to a reentrancy attack. This is checks, effects, and interactions not being implemented. Although for this particular challenge, this is not going to solve our problem. This is not going to make us the highest bidder and ensure that we win this auction. Although this is incorrect, it's a bit of a decoy. So I won't focus in on this. Let's just take another look at this external call. So in order to be the highest bidder, we understand we just simply have to pass in a higher value than the current bidder. And then we have to ensure that they cannot refund us. So if there's a new bidder who outbids us and they do try to refund us, we want to reject that refund. That's our goal. And the best way to do that is with a contract that we have control over. So my contract right here, attack.sol, it's very lean. I take the auction contract, create an instance of it, and then I call bid. So I'm going to pass the value, and I'm going to make the bid, and then the next bidder who tries to outbid me the refund's going to come to this contract, and my receive function is going to pick it up, and I'm going to revert. So they will not be able to process that refund. So that will fail. Let's bring it up side by side so you see. So here's the attack, and here's the auction.sol. So when they call over to me, my receive will pick it up. We will revert. This make bid is now pretty much deemed useless. We've created a denial of service attack, or an auction DOS attack, auction blocking attack, whatever language you prefer. Nonetheless, we will remain the highest bidder until the auction ends, and they have the end date here. All right, so that's my attack. Let's see it in action over on the test here, auction.t.sol. the test is set up where they have the auction contract, they have the bidder and a challenger. They create the new contract, and then the bidder is dealt 3. And then the bidder itself makes the bid with 1 ETH. And the challenger, that would be us, we're given 2 ETH. They do some pre-checks to ensure those values. So the highest bidder, the amount is 1. And the balance, okay, and then they have the address, and then us, the challenger, we have our 2 ETH, okay? All right, so test attack, this is where we're to apply our attack logic. And you can see this here is my attack logic. I create my new attack contract and deploy it with the auction address. I then get the current bid. So I want to know who has the current bid, not who, but what the value is of the current bid. And then I simply add 1 way. I don't have to be over by any amount more than that. So I'm going to pass just a single way more. That's me being a little cheeky. And that will be my new bid. I'll pass that as the value when I call bid on my attack contract. All right, so now that I'm the highest bidder, they're going to expect to revert the next time that make bid on the auction contract is called. Now let's move over to the terminal where I've already preloaded the command. We'll run it. So the auction challenge test attack, you can see we created the new attack contract. We then got the amount of the highest bidder. We simply added 1 way to it. And then we called bid on our attack contract, where it then called make bid on the auction contract. And then the auction contract refunded the previous highest bidder. Then there was an expectation of a revert right here. So when the make bid method was then called on the auction contract with a new highest value of 3 Ether, it reverted when it attempted to refund us. So it called our attack contract, our receive function picked it up. You can see there's our value with that 1 way on the end, and it reverted, keeping us the highest bidder. That was my approach to solving the auction exploit. If you had a different approach, I'd love to see it. If you want to talk more about mine, you can reach out to me. My contact information can be found in the details below. See you in the next one.